All right, welcome to reviewing special right triangles. So again, we're review of special right triangles. The Pythagorean theorem is a relation among the sides of a right triangle. It states that the sum of the squares of the two sides is equal to the square of the hypotenuse, or a squared plus b squared equals c squared, where a and b are the sides and c is the hypotenuse. Now here's the big deal, right? And c is the hypotenuse. Often I see my students not using the hypotenuse as c. So again, here's a right triangle. The hypotenuse is always across from the right angle. This side will always be c, and a and b can interchange, but c must be the hypotenuse. All right, so it says an isosceles right triangle has two 45-degree angles. An isosceles right triangle has two 45-degree angles. Well, that's because isosceles right triangles, that means that the legs are congruent. So for example, if these are congruent, then what will happen is that these two angles will be congruent. And so if you have 180 degrees total and you subtract 90, you'll have 90 left. And then these 90 degrees will be shared equally. So if you divide 90 by 2, you'll get 45 degrees each. All right, so we call this triangle a 45, 45, 90 triangle. There's a special relationship in a 45, 45, 90. And it says that the length of the hypotenuse is the length of one leg multiplied by square root 2. So the length of the hypotenuse is the length of the leg times square root 2. And so we could say that the side lengths are s to s to s root 2. So right here, s to s to s root 2. So what that means is that whatever the legs are, if I multiply each leg by the square root of 2, that will give me the length of the hypotenuse. I'm just grabbing some paper. And I'm going to show you why that is, because this is an enhanced class, and y'all need to know this for next year. So what I'm going to do is I'm going to draw a square. So step 1, I'm going to draw my square. So in a square, what happens is that the angles are all 90s, and the side lengths are all congruent. Now I can pick any length I want for the side of the square. Let's say that I pick a length of 1. That means all the lengths are 1. Now, where my 45, 45, 90 comes in is I'm going to draw a diagonal. And what happens is, in a square, when you do that, right, you're cutting these angles into two congruent angles. And so these are going to be 45 and 45. So I'm going to redraw that. So I'm going to make each leg, or make each side, 1 unit, which I did. Then draw in your diagonal. This forms a 45, 45, 90 triangle. So redraw my triangle. I'm going to call that side C. Remember, these are 45s. And I'm going to use the Pythagorean theorem to find C. So I get 1 squared plus 1 squared equals c squared. That's 1 plus 1 equals c squared. 2 equals c squared. And so c equals the square root of 2. Now you might wonder, well, yeah, that's because, Sedlak, you made the side lengths each 1 unit. Okay, well, I'm going to say make each side length 3 units. So if I were to do that, I'll relabel this. And that means that these would be 3s. And we'll redo the Pythagorean theorem. 3 squared plus 3 squared equals c squared. 9 plus 9 equals c squared. 18 equals c squared. C equals square root 18. And now I can simplify this one. This one I couldn't. This one, the square root of 18 is 9 times 2. Square root of 9 times the square root of 2. So that would be 3 square root 2. And now let's look and see how this compares to their statement. They said it's s to s to s root 2. So they're saying the ratio will be s to s to s square root 2. In my first example, I had 1 to 1, right? My legs were 1 to 1. And then for my radical, I got, well, there's no 1 here, but I can write 1. I got a 1 root 2. And so I have s to s root 2. In my second example, I had 3 and 3. So 3 to 3. And then my c was 3 root 2. All right, that's always the relationship in a 45, 45, 90. I'm not going to move on to 30, 60, 90. I'm going to stick with 45, 45, 90. So I'm going to skip over this part. And we're just going to work with 45, 45, 90s. This is very important for you to understand. You'll need it again next year. All right, let's look at the first example, example A. Find the values of A and C in the 45, 45, 90 triangle. All right, so I'm just going to kind of go through the example with you. It says, find the length of the leg, right? This is the leg. This is also the leg. And what I know is that those legs will be congruent. And so whatever this side is the same. And it says right here, right, the lengths of the legs are congruent. And so A is 7. And then it says that the hypotenuse is the length of the leg times square root 2. And so they're saying that would be 7 times square root 2. Or alternatively, right, for more difficult problems, for this problem, this is fine. You can just take your 7 and multiply it by square root 2. But for more difficult problems, you can draw your 45, 45, 90 reference triangle, 1, 1, square root 2, and you can set up a proportion. So you could say something like A is to 1 as 7 is to 1, right, corresponding sides. And this is already finished. You can just drop your 1s. A equals 7. And you can do something like 7 is to 1 as C is to square root 2. Cross multiply. When we cross multiply this direction, we get 7 square root 2. When we cross multiply this direction, we get C, and then we bring our equal sign straight down. All right, let's go ahead and flip to the next one. We're going to continue on with just 45, 45, 90s today. These are 30, 60s, so we're going to skip over the 30, 60, and we're going to go on to this example. This says these are 45, 45, 90s. So this is our guided practice. So it says to find the missing lengths in the 45, 45, 90 triangle, and it says to write in simplest radical form. Okay, so this one's a little more complicated than the ones that we did, so I'm going to always use that method that I showed of drawing my reference triangle and creating a proportion. So this is a 1, and a radical 2. So I'm going to go ahead and set up a proportion. Now I really don't need to for A. For A, I know that these side lengths, right, the side lengths of a 45, 45, 90, they're congruent. So A is just the same as this length, which is square root 10. And that's what it says right here, right? A and root 10 are the same. But for B, we would need to take that root 10 and multiply by square root 2. So I'm going to show it this method first, and then I'll show this method second. I'm going to create a proportion. Remember, I'm looking for B. So I would say B is to root 2. B is to root 2 as square root 10 is to 1. And then you can really see why we're multiplying by square root 2 right here. Cross multiply. B equals 2 and 10 together, right? Which is square root 20, but the reason I didn't multiply it together is because I'm going to have to break this down anyway. So B equals square root 20 is 4 times 5. The square root of 4 is 2. The square root of 5 is irrational. And so B is equal to 2 square root 5. Or we could have used this method where you just multiply the length of the hypotenuse by root 2. So square root 10 times root 2, which is square root 20, which is 2 square root 5. All right, let's go ahead and do another one. Again, I'm going to do both methods. One, and square root 2. This is the method that I prefer. And this is the method you'll see more often in Math 3. I'm just going to double check that you guys can see the whole, yep, you can. All right. So I would say A is to 1 as 8 is to square root 2. Now in this case, you can cross multiply, but you should be able to see there's no reason to cross multiply because we already have A isolated. Right? The reason we cross multiply here is to get B isolated. But here A is already isolated. And so we have A equals, now we can't leave this as a radical in the denominator. We have to put the, get the radical out of the denominator, so we're going to rationalize the denominator. So to do that, we would multiply by whatever's in the denominator. So we get 8 root 2 over square root 4. So A equals, this is 2, 8 root 2 over 2. And since there's a common factor, I can't divide into a radical, but I can divide these. Since there's a common factor, I can simplify, that's 1 and that's a 4. And so I get A equals, 4 root 2. Let me fix that. A equals 4 square root 2. All right, so it says the length of the hypotenuse is 8 units. So the length of A is found by 8 equals A times square root 2. And then they'll divide both sides by square root 2. So A equals 8 equals A root 2. And then they divide both sides by square root 2. So that would cancel out on this side, and on this side you'd have 8 over square root of 2. And then they would rationalize, and they would end up with 4 square root 2. I will always use this method, but here's another method that you can use. All right, so for the homework, you are going to work on number 1. This is a 45, 45, 90. Number 4. And I'm going to give some IXL to you as well. And later on, you're going to see how 45, 45, 90s come into play on the unit circle. So the unit circle, this is a huge idea that you need for Math 3. And it's all 45, 45, 90s. Here's our 45s right in the middle. And then our 30, 60, 90s, there's 30 and 60. There's a 60 and a 30, a 30 and a 60, and so on. And so you're going to need these special right triangles to understand your unit circle. All right, guys, I'll find you some IXL to go along with that, and have a good day.